We have here addition of complex fractions. First, we need to do operation in the parentheses. We have subtraction. We know that we have to have the same denominator, n square, n cube. So the denominator will be n cube. So let me rewrite our numerator. We have 1 over n minus 2 over n square minus 3 over n cube, and in the denominator we have 5 over n plus, and because we have fractions, so I will put n plus 6 over 1 to have fraction. It's still the same expression, I didn't change anything, and we have plus, we have 9 over n to 4th power minus 1 over n square, and we have 2 over n minus 15 over n square, and we have plus 1, so I will change this to fraction also, 1 over 1, so this is equal. Now, like I said, we need to have the same denominator, n square, and n cube. Like I said, the denominator will be n cube, because n cube is divided by n square and by n. So now I need to multiply n times n square to get n cube, because n is like invisible 1 here. So the same base, we add exponent, so it will be n to 3rd power. So everything is okay. Whatever I did with denominator, I have to do the same with numerator. So I have to multiply 1 times n square. Now we have n square in denominator, so I need to multiply times n to get n cube. Whatever I did with denominator, I have to do the same with numerator. And the third fraction is okay because we have n cube. Now we have in denominator n and 1, so denominator will be n. So I need to multiply 1 times n, and whatever I did with denominator, we have to do the same with numerator. So n plus 6, I have to multiply times n. And let's go to the next numerator. We have n to 4th power, n to 2nd power. We have subtraction, so we need to have the same denominator, n for n square, so the denominator will be n to 4th power. So I need to multiply n to 2nd power to n to 2nd power to get n to 4th power. Whatever I did with denominator, I have to do the same with numerator. And the last expression, we have n square and 1, so denominator will be n square. So I need to multiply n times n to get n square. So whatever I did with denominator, I have to do the same with numerator. Next we have n square, so everything is okay, and 1 I multiply times n square, and numerator times n square. So now we will have 1 times n square is n square, over will be n times n square is n cube, and we have minus 2n over n cube minus 3 over n cube. And in the denominator we have 5 over n plus, we have n plus 6 times n over n. We have plus, we have 9 over n to 4th power minus 1 times n square is n square over n square times n square is n to 4th power. We add exponent, 2 plus 2 is 4. We copy base and add exponents. And the denominator we have 2 times n is 2n over n times n is n square minus, we have 15n square, and we have plus 1 times n square is n square over n square will be. Now when we have the same denominator, so we can copy the denominator and we subtract numerator. So we have n square minus 2n minus 3, and here will be n 5 plus, and we can do multiplication, n times n is n square, 6 times n is 6n, and we have plus will be, the denominator is n to 4th power, and now we have n minus n square, and last denominator is n squared, so we have 2n minus 15 plus n squared. So this is equal, we have division, because this fraction bar means division, so we can rewrite first fraction, this main fraction bar I will change to division, so numerator I will copy n squared minus 2n minus 3 over n cubed will be divide, and we have 5 plus n squared plus 6n over and we have plus. The same we will do with a second fraction. This main fraction I will change to division, so we have 9 minus n squared over n to 4th power, divide sign, and we have 2n minus 15 plus n squared over n squared. So this is equal. Now when we have division of algebraic fractions, we have to copy first fraction. We have n squared minus 2n minus 3 over n cubed. Division sign change to multiplication, and we have to flip the second fraction, so it will be n over, and I will start from the highest power, so we have n squared plus 6n plus 5. And we have plus first fraction we have to copy. Division sign we have to change to multiplication, and we have to flip the second fraction, so it will be n squared, and I will start from the highest power, so it will be n squared plus 2n minus 15. So this is equal. We know that first we have to do multiplications, next will be addition. So let's see what we have here. We have quadratic trinomials, so we can try to factorize, because we have different term in numerator and in denominator. So let's see. You have n squared, so we need to put n at the beginning. N times n give me n squared, and now when I multiply two numbers I need to get negative 3, and when I add them I need to have negative 2. So will be negative 3 and 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So everything is okay. And because I have here n, so I will rewrite n cubed, that this is n squared times n. We have times n. Now we will try factorize n squared plus 6 and plus 5. So I need n squared, so first I will put in parentheses n and n. N times n give me n squared, and when I add two numbers I need to have 6, and when I multiply these two numbers I have to have 5. So it will be 1 and 5. 1 times 5 is 5, and 1 plus 5 is 6, so everything is okay. And we have plus. What we can do here, we have 9 minus n squared, so 9, so this is 3 to second power. So I can rewrite that this is 3 minus n times 3 plus n. I just use formula when we change 9 minus n squared, this is 3 to second power minus n to second power. So this is difference of two perfect squares. So I can use formula that a squared minus b squared, this is equal a minus b times a plus b. In our example a is equal 3 and b is equal n. So this is from that formula, and we have here n to 4th power, and we have n squared. So I can rewrite n to 4th powers, but this is n to second power times n to second power. The same base we add exponents. 2 plus 2 is 4. So the same what I have at the beginning, and we have times n squared, and Now we have n squared plus 2n minus 15. So again, we will try to factorize. We have n squared, so will be n times n is n squared. And I have to find two numbers which I multiply, and I will have negative 15. And when I add them, I will have 2. So it will be negative 3 and 5. Negative 3 times 5 give me negative 15, and negative 3 plus 5 is 2. So everything is okay. So now we can first reduce n with n. We can cancel out n plus n and n plus 1 with n plus 1. What else we can reduce? N squared with n squared. And here we have 3 minus n and n minus 3, so we have the same number and variable, different signs. So we can factorize negative sign from this term, and we will get the same what we have here. So let's copy the beginning. We will have n minus 3 in the numerator over n squared times n plus 5 only. And we have plus, like I said, we will factorize negative sign, so it will be negative 3 plus n, and the rest we will copy. We have 3 plus n, so first I will put variable n, next 3. And the denominator is n squared. Now we have n minus 3 times n plus 5. So this is equal. We have to copy first algebraic fraction, so we have n minus 3 over n squared times n plus 5, and we have plus and minus, so I can put negative sign, and in parentheses first I put variable, so it will be n, and next negative 3 times n plus 3 over, we have n squared times n minus 3 times n plus 5. We see that in parentheses we have n minus 3 and n minus 3, we have multiplication, so we can reduce. So now we have n minus 3 over n squared times n plus 5. We have minus, and numerator we have only n plus 3, denominator is n squared times n plus 5. We have subtractions, we have the same denominators, so we have to copy denominator, and we have to subtract numerators. We have n minus 3 minus, before this whole fraction we have negative sign, so I have to put in parentheses n plus 3. So this is equal. Denominator we have to copy, and we have n minus 3, negative sign, so we need to change the sign in parentheses, so it will be negative n and negative 3. So this is equal. N and n, we have n minus n, so we can reduce. So now we have negative 3 and negative 3 is negative 6 over n squared times n plus 5. This is my solution.